Good morning, all. We'll get started in a couple minutes. Thank you all for joining. Today's topic, I think Cisco will be going over the deterministic link, bringing up for the ports with SFF compliance modules. Do we have Lingian in the bridge?
Hi, yeah, I'm Nongyin, so I'm here. So shall I start to share? Or?
Yes, go ahead.
Yeah, let me share. So it says it's share a field. Sorry, it says sharing field. Is there anything I need to turn on to share?
No, just make sure you're sharing. You're trying to share just the particular application or the whole screen?
Particular application.
Okay.
But it still says, yes. Sorry. Oh, yeah.
Yeah.
I think.
Yeah, we can
good.
see it. Yeah. Sounds good. Go for it. Thank you.
Okay, thank you. So yeah, so hello, good morning, everyone. So today I'm going to present that deterministic bring up approach for SFF modules. So let's go to the section. So basically, this is the high-level design document describe the need and flow of the deterministic link bring approach for SF compliant modules. So there is already a parent HOD that is focused on the high level background and some idea, some generic ideas. And but but it's only for SONiC module. So it provides some details for SONiC module. It provides some common idea, but most focus on the SONiC module. So this HOD will focus on the SFM module. So let's go to the, so this is the reference for the parent HOD. And let's go to the problem definition. So currently in SONiC, so for the 100 gig and 400 gig optics module, so there's no synchronization between the TX enable, the laser TX enable, and the ASIC TX. So this potentially may cause some link stability issue, and during the system boot up or during the interface admin status bring up. So the second problem is that when we are doing the interface shutdown Ethernet, this will bring down the admin status. So ASIC TX will be disabled, but the optics modules TX laser will still be on. So this will lead to some power wastage and also some unnecessary fan consumption. And last but not least, so the potential lab hazard when the port is still shut off, but the laser is still on. So in order to tackle this problem, so handle these problems, we bring in the deterministic bring approach for those SFF compliant modules. So below, this is the sequence we are going to follow. So first, we are going to initialize and enable NPU, TX, and RX path. So make sure it is stabilized. And then for the system with external PHY, so we enable the PHY TX and make sure they are stable. Then eventually we are going to perform the optics TX enable. So this plan, in order to achieve those objects, so we plan to add a new thread called SFF task manager inside the transceiver D. So this thread will subscribe to host TX ready. So this field it's already existing in today's port table in the state DB. So this field is going to set to true only when the admin status is true, and also the when we are setting when the syncd and GB syncd they return successful when we are setting the admin status. So that means at the time of this field is true, so the NPU and PHY TX is already enabled. So this this new thread SF manager will, based on this host TX ready, and it will go ahead to turn on the TX or disable the TX. So breakout handling, we already talked about in the parent HOD. So it will be following that. So since this host TX ready field is created for each interface, so we will handle them per interface. So even if it's breakout, so it can handle the property. So that's it. Then let's go to the feature enablement. So this feature would be enabled in per platform basis. So there could be some cases that the platform take time to shift from the existing model to this new model. So by default, this feature is disabled. So in order to enable this feature, the platform need to set a enable transceiver SF manager flag in this pmon daemon control.json, and it needs to be set true. So once it's set true, so the transfer D will launch this SF manager. So there is the
comments. One comment here.
Yeah, sure. Yeah.
Okay, it's Eddie from NVIDIA. You might want to align to existing variable. Seems to me skip skip CMIS manager. Okay, it is for platform not supporting CMIS management. Okay, so you may want to put also skip SFF manager. So when either of them is set to true, okay, so relevant task is not launched. Okay, just for alignment.
So we have that. I think Longin will explain it further down. There is a flag introduced for the SFF purposes, similar on the lines as CMIS.
All right. Okay, so we can define two variables. Okay, in JSON in daemon control JSON of the same style, right? Okay, skip and yeah, similar behavior.
Yep.
Yeah. So we think of that adding skip flag, but since this feature is disabled by default, so we are thinking of using this enable flag instead of the skip flag, because if we use skip flag, then it is enabled by default. So that's not what we want to do. So we want so only with enable flag we can achieve the goal to disable this flag by default.
It can be set to true by default. Okay, so in this case, task will not be started.
Yeah, the thing that if this we want to set the skip flag, we add the skip flag and set it to true by default, then the existing platform, they don't have this flag, right? So then how do we achieve that? So that's, we don't want to impact the existing platform. That's one of our goals. Yeah, okay.
Okay, in this case, okay, we will have two different behaviors. Okay, similar flag, exactly. Yeah, same flags.
Yeah. Yeah.
But I think the purpose is different here. That's why Longin is mentioning by default for SFF, it is disabled for every platform, and whichever platform wants, they can make it true. But for CMIS, it is reverse. Hence, different naming convention.
Yeah.
Okay. So actually, we're extending now module management, software-based module management. Previously, it was only for CMIS modules, and now for optical non-CMIS modules, right?
Yeah.
Yes, correct. Right.
Okay. Yeah. Yeah. Thanks for the comment. So that then let's go ahead. So for next, we're going to talk about the prerequisite so for people platform enable this feature. So being able to before they enable this feature, the platform needs to make sure the transceiver is kept in TX disable state when the module is inserted or during bring up, during the system bring up. So because this is to make sure the transceiver is not transmitting with TX enabled before host TX ready is true. So this is the prerequisite for the platform. Then we're going to go over some important workflows. So regarding the prerequisite flow in the insertion and the boot up cases. So first, the platform brings the module out of the reset. Then platform keeps module in TX disable state immediately after the module out of reset. So after that, the transceiver will detect the insertion based on the platform hook and update the module status to DB. So next, upon the module insertion event, SF manager, because it's listened to the DB, so it will take the action accordingly if needed, either turn on the TX or either turn off the TX.
So what exactly will be the trigger for SFF manager to start running?
To get SF manager start to run, so platform first needs to follow this prerequisite, then also needs to add this enable SF manager flag in the PMON daemon control.json. So these are two things platform needs to do.
No, but what will be the trigger? A change in what, in transceiver info table in StateDB, which is updated on insertion removal, or which when hostx ready?
So because SF manager will listen to the hostx ready, this is the field in today's DB, so it's already existing there. So we just listen to that and take action accordingly.
Okay, so we will have two threads, right? CMIS manager task and SFF manager task, both registering for changes in hostx ready, and each one we will handle only CMIS or non-CMIS optical models, right?
Correct. They handle different module.
But with the same trigger, right? So same trigger will,
yes, same trigger.
Cause both threads, okay, to wake and run.
Correct.
Same trigger because it's on the trigger is on the port or the interface. And which optical module to handle it for, whether SFF or CMIS, that transceiver D or the respective thread of the transceiver D knows.
So this is flow for the when platform add the enable flag. So basically, transceiver will only spawn this thread when this flag is set to true. So next, we're going to the this is the flow when we're calculating the target TX disable value. So when we're saying TX disable value, we're meaning that when TX disable value is true, it means TX is disabled because this is the this value is about TX disabled. So when this TX disable value is set to false, it means TX is enabled. So this value we need to calculate before we SF manager takes the TX related action. So here we, in addition to hostx ready, we also add the admin status check. So this is just to add another sanity on top of hostx ready. So and this is comment from Prince. So we check if only when both hostx ready is true and the admin status is up, we turn on the TX. For all the other case, we consider the TX should be off. And next is about main flow. So main flow of SF manager. So this flow will cover all the three situations. For it will cover system boot up, cover transceiver insertion, and cover admin status enable disable. So here, this can be larger. Okay. So in the beginning, so asset manager will subscribe to those DB events. It has a hostx ready and admin status, those kind of event. So then it will enter a while loop for the thread. So for each in each while loop, so we will check. We will go to check the hostx ready change event and the admin standard change event, and also the insertion module insertion event. So these three events we are going to check, and if neither of these events happens, then we go back to the while loop. If if at least one of the event happened, then we will go inside to the main flow. So we will first we will fetch the DB, and if the hostx ready value is not existing in local cache, we will fetch it and update it. Similarly for the admin status, if the admin status is not present in the local cache, we will go fetch it from DB. Then we go ahead to double check the module if it's present. This will be there will be a platform API call. So it's not a platform API; it's a common API. So common API that will try to read the EEPROM, not EEPROM. It's try to read the GPIOs. It depends on different platform, but this would be just additional sanity check. Then it will calculate the TX disable value based on the host TX ready and the admin status. So the calculation we just described above in the above flow. Then once we have the target TX disable value, we go ahead to check if the current TX disable value on the module is the same, then we don't need to take action. We can go back. If the current TX disable value on the module is different from the target one, then we go ahead to enable or disable TX. Yeah, so this is the end of it. Yeah, this is the end of it. I think that's it. So anyone has any question or comments? Yeah, if we are good, then okay. Thanks very much for taking the time to listen to this presentation. Okay, thanks.
Thank you so much, Lingen. Anyone has any questions, guys? All right then. Have a wonderful rest of the day, guys. Take care. Thank you.
Thank you. Yeah.